Okay, hello everybody. I'm going to try to show you guys how to use the iPad version of ExploreStars. This thing is very similar, almost identical to the Android version of ExploreStars. So if you have an Android, you want to watch this video, and if you have an iPad, of course you've come to the right place. So see on the screen here we have our iPad Wi-Fi settings area, and we're going to connect to the PMC-Eight. Here we go, I hope. See what happens. And there we go. Now we've got it. And the IP address is 192.168.47.11. And that needs to be the IP address for your PMC-Eight after you've connected to the PMC-Eight network. So I'm going to open up ExploreStars. There we are, ExploreStars. And you can see at the ExploreStars screen now, we can see on the left we have a compass rose, and we'll talk about that more in a moment. On top we have the site data. We have our OTA data below that, and our target data. On the right we have a keypad with numbers, and the numbers are used to change the rate at which the LRDU buttons, the left, up, right, and down buttons, move the mount. And you can see I pressed the number 8, and I have a number 8 in the center of the box there between these 4 LRDU buttons. There's the number 4, there's the number 1. These buttons don't relate. They do relate directly to serial, but I don't know exactly what that relationship is. Generally for centering, I used something along the lines of 7 or 8, sometimes even 9, at least for moving rapidly, and centering more like 4 and 5. But you can do what feels good to you. We have the keypad down here for the up, down, left, right. That moves the mount in generally those directions. We also have a TR button, a down button, the OBS button, a go-to, and an info button. And we'll see how to use those in a moment. We also have in the middle of the keypad there, we have sync and menu. Oh, now I wanted to point out, by the way, on the OTA data, when you boot it, you will see that the mount should come up at declination 90, and your altitude should be equal to your latitude. And you can see here that that's kind of about where we are. This particular mount, you'll notice that now if you look at the RA, you'll see that it's sitting at 2350.25, and it's not changing. That tells you the mount is tracking, and that's because my Exos 100 here, iExos 100, was set to begin tracking immediately upon boot, so it's been running along. So one of the things we can do just for fun is we'll go to the menu, and now we get to see how that works. Brings up your sub-menus, and we're going to go to settings, and we're going to use the bottom left button that says park, and we're going to park the mount. And we can watch that the deck now has been moved back to 90. The altitude is now precisely my latitude. And the, you notice the azimuth is 360 because I have to be pointing north. And you'll also notice now that the right ascension ticker is going along tick, tick once per second. And that's because the Earth is turning. And so the right ascension is turning because the mount is no longer tracking because we are parked. All right, well, let's say that we wish to go see a target of some kind. So we're going to go to the menu, and we're going to pick ourselves a target, and that would come from the catalog page. On the catalog page, we have a scrollable series of targets. These are set up. In the top, you can see the Messier, NGC, Solar, Bright, Andromeda is there as a search, and Tour, and search. So we're not going to do any of that at the moment. Instead, we're going to go back to the Messier objects. We'll find ourselves one, M2 for example, which is apparently visible. And so here we are. This pops up information about the object, which we can scroll and look at. And it also tells you can slew to the object. If this object had been below the horizon, you wouldn't have been able to slew to the object. So now we're there, and you'll notice that the mount is not moving, and that's because I have it set to not move until I push go to, and we'll show you here in a second. I'll show you how to do that. So let's just go to this target, and there we go. You can see the RA and the deck are changing, as are the altitude and the azimuth. Now you notice the target data field is now illuminated and filled in with the M2, which is the target name, and its right ascension and its declination, so we can watch as the mount moves itself over there. Alright, we've reached the target now. I want to show you why it was that it waited for me to do a go to before it took off. So in the menu, settings, we have the top left we have 4 buttons: hiding alignment data, hiding debug data, auto align off, and target log off. Now the auto align off is the button that sets whether it takes off or not. There's auto align on, you touch it, and you touch it back. So that was auto align off. Let's go do a go to and watch what happens when auto align is on. So we'll go to the menu, and we're going to go to the catalog. And let's find another target somewhere. M15, for example. You see it there in the center, the right center of the screen. I'll touch it and slew to object. And you'll notice immediately, without having to go to the go to, the RA and the deck are changing, and we're off to the races going to the target. Now that might be something you wish to do. I personally like to leave auto align off. I don't want it going to the target automatically like that. I like to be able to stop and think about it for a second before I push go. Auto align has another interesting feature relative to the 3-star or 2-star alignment. We'll discuss that in a moment. I want to go back to the menu though and show you some other little items there. Catalog. And I wanted to take you through these things. The NGC button shows you NGC numbers and those objects, as well as the ICs. We have solar. Solar brings up all of the objects in the solar system that we could go track. I'm indoors. I don't have a scope on this thing. This is a mount running raw. We'll go right to the sun. Let's just do that. And off we go. And so we're going to the sun. And you can see ExploreStars had a pretty little picture of the sun there. Now as it's moving, I want to point out to the little, in the center of the screen here, you see that you can see on the front of the sun there's a little red meatball there. That meatball is actually a joystick. And if you touch it with your finger on your touch screen and you drag it to the left, right, or up or down, you'll notice that the mount is now moving. And if you can tell that by looking at the OTA data. And the farther you move this thing, the faster it goes. And if you let go, it returns to center and the mount will stop. Now I've moved very far off the target, and I can just now at this point get back to the target by pushing the go to button. And the target is remembered and it goes back to it. So you can always get back to where you started if you're using the joystick. The joystick takes some practice using, and I've not used it enough to have any facility with it, so I never use it. I don't think it's really that useful for me. You may like it though. It's kind of a personal thing. Off to the menu again, and the catalog, and we'll just look at the bright stars. Now the bright stars are all of the ones in the catalog that this thing can use. Probably a bunch of others as well for the 2- and 3-star alignment, or if you just want to look at some stars. Now we can find a star by its common name or by its designation. In this case, I've touched up in the search bar there. First let me get search, so I'll bring up, that's now I get a keypad, and I'm just gonna say like Polaris, P-O-L-A-R-I-S. All right. Alright, so now we have lots of things that should be somewhere in here. Polaris, let's see. Well, where am I missing? There it is, right there. So we're going to, it's an Ursa Minor, and Polaris, we'll just touch that. And we'll salute to the object. And we're still, there she goes. At this point you can see on the constellation diagram, we have the little constellation drawn, and Ursa and the Polaris is highlighted with the meatball. And that's one of the things that will happen with stars. It'll also happen with other objects, and you'll notice that they won't be located on a star anymore. The meatball will not be, because the object is not there. So it gives you a general indication, though it's not a planetarium program exactly, but it gives you a general indication of where within the constellation the object that you're slewing to is located. Now I want to show you that the mount is moving, but as soon as I were to press a button, you notice the mount has stopped, and it's not where it's supposed to, where it is heading. And that's one of the features. If you ever need to stop the mount, just press a button on the screen. It doesn't matter which one. We'll go back to main. We'll continue the slew with a goto because it knows where it's going. And I'll just change this rate number, and it's instantly stopped again. So you can touch any of these buttons essentially and stop a slew if you want to. Now the firmware knows that when the slew is to stop, it stops slowly, so it takes about 2 seconds to ramp down. So you can't hurt it as you're going off, and you were to stop it like that. So the mount will protect itself very nicely. Okay, so we're going to go back to the menu now, and let's just go over a common thing that people have trouble doing. We're going to go to a 2-star alignment. And I'm just pressing the buttons as needed. 2-star alignment. This 2-star alignment takes you through a dialog which is going to run you through multiple stars to align the mount. Now the alignment would in that instance would be a virtual alignment. That is to say, the mount is not actually polar aligned, and it's because you didn't mechanically polar align it. But the virtual alignment allows the computer program to calculate where the mount has to point on a moment-by-moment basis to rotate the right ascension and declination axes, even though you're not polar aligned, to where the star is. Now you might have noticed it immediately took off and went to this object, and I don't like it doing that because this might not be an object I want to go get. You see, when you're doing your 2- or 3-star alignment, that object may or may not be where you can see it. It might be behind your house, behind a tree, things of that nature. So it's useless, or actually not very beneficial, to have the mount take off immediately. And that's where, back to the menu, we're going to find in the settings the auto align on and off. We're going to turn that off so that that takeoff will not occur. Alright, so back to the main. And I don't like this one. I'm going to ask it to go to the next one. Oh look, there is another potential object. I don't like that one. We'll use this one. Okay, I can see Hercules. That works for me. I'm going to go ahead and go there. So I'm going to push go to. And off it's going to go. Why did I pick that one? Because as I looked around my sky and my trees and my obstructions, I could see that star. I could see that constellation. I knew I was going to get there. So off it goes. Now the mount, if you're not polar aligned, will not actually get to this object. It'll be in that vicinity, but it won't be the correct place. So what you're going to have to do is move the mount with the LRDU buttons to center that particular star into the eyepiece. I can't simulate that. Well, I can simulate it here, but I don't want to do it. We're going to assume that it would hit it right on, and we're just going to use the location so I can show you what happens to the alignment data. But the fact of the matter is you'll need to center every time. And it's important that when you do that centering, you get it exactly centered, and that it's rather precise. Sometimes you'll find that you're off on this on the star positions, and that is caused because the mount is not polar aligned to begin with. It also probably isn't level, and the whole thing has really very little idea it is a very vague idea about where everything is in the sky. So it goes to where it would be if you were polar aligned and if everything was copacetic, and that's where it's going to sit. Now the star field might drift because if you're not polar aligned, that's what happens. In any event, we've gotten it centered now in our little virtual alignment here thinking about this, and I like what it is, so I'm going to use this enter button, which is at the bottom below the name, to say I like it, it's centered, now please use that value. Now, it's gone over to links in Leo Minor. I don't want to do that. I'll go down, I'll just fool around here, and we'll pick that guy. So that was the one I wanted to go to. And we'll just do a go to and off we'll go. Now one of the things you can do is you can use a planetarium program. I recommend everybody get one on their phone. And you can use that so that you can identify, oh, no, Auriga, that's the star I have to go to. It's that one in that lower corner there. You can pick the name up. I'm not even going to try to pronounce it in your planetarium program, so it can absolutely arbitrarily identify it for you as you look into the night sky. And you want to be sure to center on the correct star. If you don't, you're going to get a very, very poor, bogus, in fact, alignment, and it's not going to do a go-to at all. So we're still going there, and it's going to eventually get there, I think. We hope. We're already there in RA, and deck is converging here. And there we are at deck. Alright, well, I've centered it now conceptually, and I'm all set, so I'm going to hit enter, and that's it. We're now auto-aligned. But how do I know? How can I see how well I did? Well, in the menu, I want you to go back to the settings, and you see one of these 4 buttons was hide alignment data. Let's not hide the alignment data. It's the upper left button. Let's show the alignment data. And now we're going to go back to the main by pushing the little home button in the upper left corner. And at the bottom now we see the alignment data. This screen here will scroll if there's any more to show. In this instance, it all fits. You'll notice that the alignment data at the bottom now has values of basically about 1 and 0. And this is actually a 3x3 matrix. And it's roughly a diagonal matrix. And so location 0, 0 is the upper left. 1, 1 is the first row, second row, second column, and you'll notice it's a 1. And 2, 2 is the third row, third column. It's also a 1, and the others are about 0. Well, this is what you'd expect because I was quote-unquote perfectly polar aligned because it did a perfect go-to and it was centered exactly on the star, and I accepted where it had gone. If I had diddled the star at all, the position of the star at all, I would change these numbers. If those numbers are not in that vicinity of 1 and 0 like that, and they can be a little positive, they can be negative, but they should be small. If they're large, you've centered on the wrong star, or you've done something to the wrong, and it will not do successful go-tos. It just won't do it. So you always would want to take a quick look at your alignment data after you've done the 2 or 3 star alignment. I recommend you use the 2 star, especially until you get used to it. It's perfectly good. It gets you there, and for visual use, it's going to be fine. So that's the 2 and 3 star alignment. And let's see, what else to show? Let's go back to the settings, and let's go over some more of these buttons in the setting. We have a button there to load GPS coordinates on the left, and that does what you'd expect it to do. It brings in your sight lat and long off of your tablet's notion of where you're at. I want you to notice that the longitude is minus in this instance, and that's because I'm in the Western Hemisphere, so you'll always want to have a minus number there. The scope IP, that is the address of the server that's in the Exos, and it's always 192.168.47.1, and the UDP port needs to be 372. These things are subject to change, and if you try to change it, it basically crashes the program for some reason. So that actually doesn't happen on Windows, but on the Windows ExploreStars, but you cannot change it here in the iPad, nor can you do it in the Android version of this thing. Alright, on the upper right, these are kind of important buttons, so let's look at that. We have a button that says using firmware. That is used by ExploreStars to know that it should go and ask the mount, what kind of mount are you? Now those of you that have a PMC-8 and have used it for a while know that the firmware needs to be configured to the proper mount type that you have. When you buy it from the factory, it comes in already set up for you, and it knows it's an iExos 100 in this instance. But if you bought an Exos 2, it would know that. If you bought a G11, it would know that. It's set in the firmware and remembered by the firmware. But the firmware is universal to all of these mounts, so it needs to be configured. So it's already been configured in the factory. Now, if for some reason, if you're using firmware and the mount type comes up and tells you it's an Exos 2 whatever, and it's not the one you have, you can go back to, I pressed using firmware and I said, well, you can ignore the firmware, and then you can ask it, you can tell it what kind of mount you have. You see what happened when I pushed the mount type? I popped up this rolling thing at the bottom. So I'm just going to pick the Exos 100 because I know that's what it is, and I'm done. And so there we are. But oh, let's do this. Let's go ahead and for fun, let's tell it it's a G11. All right, done. And now let's use firmware. And look, you notice it changed it right back to an Exos 100. The RA steps and deck steps, you can change those, but you shouldn't. Those are the total number of motor steps that are needed to run the mount around any of the two motors around 360 degrees. That's very specific to the motor type and the gear ratios. And so they're going to be different for the different mounts. And you want it to be exactly that for the Exos 100. It turns out the Exos 2 has the same exact setup in its drivetrain, so it also would be those numbers. The tracking speed is the number of, it says 48, and that is the number of microsteps per second that the stepper motor is applying. And the observation size is related to the size of the spot and space that the OBS button uses. And we haven't talked about that yet, so we're going to go to that in a minute, I guess. All right, let's go to the bottom. We have the 3-star and 2-star alignment buttons, and we just went through a 2-star alignment. We have a stop alignment button. This is what you would use if you'd started an alignment and you'd just gotten wrapped around the axle and you just wanted to stop. So you just push stop alignment. That gets you out of the loop. Remember, it was in a little program loop going 1 star to the next to the next. This is how you would get out of that. And there's a reset alignment next to that. This is the thing that would set you back to no alignment data at all. And sometimes if you've made a bogus alignment, you might hit that reset to start over. It turns out when you start an alignment, it also resets it. Personally, belts and suspenders, I reset the alignment and then I restart the alignment. But you don't have to. We have a park button down at the bottom left. That moves your mount back to the park position, which is really the for the ExploreStars, that's the same as the home position if you're used to thinking about home, and it's hard-coded to where the motor counter is 0, 0. And that is, you've set your Exos up at polar home. And that would probably be the subject of another video. And reset comm link, that's a button that is used sometimes, particularly in some older firmware versions. I'm not sure it's needed anymore. It attempts to restore the comm link if it gets dropped. I've never had much luck using it, but it might be effective. So if you think you've lost comms, you can try pushing that, and then when that doesn't work, we'll go on and figure something else out about it. Okay, we're going to go use the little house button here. We're going to go back to the main screen. I want to point out we have a button on the screen here, which is both an indicator and a button. And right now it says TR. The TR button is used to set the track mode of the mount. Now the mount can move in 2 different ways. One is in sidereal tracking, where it runs the right ascension at sidereal rate. That would be the TR mode. The other way is to use, I'll press the button and it turns to P. And I think that really stands for point mode. I like to think of it as program mode, point mode, program mode. The 2 modes are different. In P mode, we'll just short it that. The ExploreStars is calculating instant by instant the position of the mount the star or the object, and it's sending out right ascension and declination commands. These are happening 5 times a second, well, two and a half times a second for each of the axes to keep you centered on the star, and it's employing the alignment data to do so. So it's calculating the actual star position, the motor positions needed based on that alignment data, and this is how you can have a non-polar aligned mount but still follow an object, and that happens quite well. If you're in T mode, and I'll put it back, or TR mode, you're now tracking, and the mount at that point is being commanded to move on the right ascension axis at sidereal rate, and the deck axis is not moving at all. And so that's the mode. So T and P have those properties. If you're going to do visual, you could run P if you have an alignment, if you've done a two-star alignment. If you're polar aligned, mechanically, you can just run TR all the time. You needn't run P mode, and you need not do a 2 or 3 star alignment. I want to emphasize that your 2 and 3 star alignment are only necessary if you are not mechanically polar aligned. I've found that if you mechanically polar align, ExploreStars is much happier, and you get a much better result in terms of your utility. Because personally, the 2 and 3 star alignment for me has always been a difficult thing to achieve and have good results, though I've done it, and it's very good when I do it right. But it's, as you may have noticed if you haven't already, looking through the eyepiece and manipulating the LRDU buttons on the screen of your tablet can be troublesome. Alright, so we've got that. I want to get rid of the alignment data here, so we're going to go to settings, and we're going to reset them. And we'll go look at them again, and we'll see now that they're all 0. Now, any of you that know mathematics go, well, you can't just multiply something by a 3 by 3 matrix of 0, you'll get 0. Well, that's right. So obviously this ExploreStars knows there's no alignment data, and rather than doing anything with the matrix, it's doing nothing with the matrix. So that's how that happens. Back to the settings, and we'll just turn off the, we're just not going to show that alignment data anymore. I'll show you the debug data. You notice below the hiding alignment data, now we have hiding debug in the upper left. We'll press that button. Now we're showing the debug data, and here's the debug data. The debug data lets you see things like the right ascension axis motor counts, and you can see them incrementing along as things going. Is it incrementing? Yes, it is. The declination axis, the D line here, it's sitting solid, not moving. We have restatement of your motor counts and your track speed. And that data is really not much use to anybody that's using the mount, so I wanted to point it out. It's kind of fun to look at, but you needn't use it, so we're going to go turn it off. Settings, and we're going to turn that show debug data off. Alright, oh, we haven't done coordinates. Let's do coordinates. Coordinates is a nice place. So if you wish to go to an as and L, let's say that you desire to, I don't know, park or move the thing so that you can look into the tube without having to strain your neck. Well, that would be an altitude maybe of 0 degrees. And an azimuth, let's say we just wanted to go to 90 degrees azimuth, which would be looking east, right? At least for me. So let's just do that. We're going to submit it. And the mount's going to take off. And it's going to go to, I hope, 0 and 90 degrees. The altitude is coming down. It's at 4 now, and 3. And there it is coming into 0. And the azimuth is 90, and it stopped. Now I want you to notice that the right ascension axis is, the right ascension shown on the OTA data is clicking now, because when you do a directed move like that, the mount will go and stop. You can begin it by pushing track, and now it's tracking. So it just wants to go and stop when you do a directed move. Let's see here. Let's just go back to menu. Is there anything else I need to show you? We did coordinate. You can also add a right ascension and declination if you know them. An interesting test would be to see if it goes there and stops. I honestly don't know. My assumption is it will stop. Okay, you think I would know. I coded it, but I don't know. At least I've been all over the code. Alright, about is going to give you some information about the thing. That's fine. It's all great one time. Help is not there. Now I promised I would tell you how it differs. In the Android version, if we were to start a 2-star alignment, and we didn't like any of the stars we were seeing, we could go to the catalog page, and this page would look different. It would look like this, but it would also say across the top, right under the buttons, select your first alignment star. And you could scroll through and select whatever star you wanted to be your first alignment star. And you would then push, you'd push it and select it, and you could go to it. You'll notice it didn't do it. And that's because this is the Android, this is the iPad version. It's sitting right where it was at Hercules. Let's try that again. I'm going to try to tell it where to go. Menu, catalog. Let's go to Alpha Sculptus. And you notice it didn't do anything. That's how it is on the iPad. But on the Android version, it goes right where you asked it to. And it clues you in also. I wanted to go over the OBS and the info buttons with you as well. So let's just, first let's just go somewhere where we're going to be happy with knowing where we're at. And, oh, fudge. Here, I'll try that again. Let's do the catalog instead. And let's go to a messy object. Let's go to a more interesting one than those other things. We'll go to M29. Off we go. And go there. Go to. So off we go. And we're there. So I'm going to press the info button here. And what do you know? I now have the information the same as if I had just selected it and remembered to read it. So, oh yeah, somebody wants to know, well, what is that thing? Well, here it is. And you've got that information all laid out for you. Back home, we're still on the target, happily tracking away. Now, I'm sitting there in Cygnus, and I want to go, well, what else is around there? So I'm going to push the OBS button. And you'll see that all of these stars that came up are all in that same region of space. And it also pulled up M29, which I think is where we're at. So we could go to any of these stars we wish, because they're in that local area. Let's do this. Let's do a Messier object. Let's go to, it's probably below the horizon. So it's like, oh, that's not. We'll go to Andromeda. Yeah. I fooled around long enough today. It's now risen. There we go. There we go. Cool. So there we are. And let's do OBS. Oh, we have M32. Well, yes, of course we would, wouldn't we? We would have M32 right there next to M31. So that's kind of cool. And we also, maybe we didn't know that M110 there, M110 is right next to it. So we could go there too. And let's just go there. And it shouldn't be much of a slew because we're supposed to be in the region. And in fact, it was very little. So there you go. So that's what the OBS button does for you. Now in the settings, we noticed there was an OBS size. And I've never done this, so we're going to do it right now. We're going to change that to 1. Whoops, maybe we're going to try that again. Hello. OBS, please. Let's go back. Show keyboard, please. And I didn't use you. I'm sorry. Don't beat me. Okay, and there we are. And let's just push the OBS button and see if it changed anything. I believe it has less objects now, as it should. So we just verify that we're going to go change that button right now. Settings. And the OBS size now, we'll change it to a big one. We'll go to 3. And done. And let's go back and go OBS. Oh, look at all the stars. So that's related to the size of the field of view. I don't know what the calibration on that is, but the bigger, the more sky. Now, no explanation of ExploreStars would be complete without discussing this little button right up here, this sync button. And sync is one of those things which people need to understand. If you press the sync button, what it does is it tells the ExploreStars app to associate the current motor counts with the present right ascension declination. So it's in this manner, it kind of recalibrates, or at least changes the relationship between the motor counts and the sky position. Now, why is this important to do? So if you do a polar alignment and you have some polar alignment error, or if your go-to is a little bit incorrect, you can center on a target and then you can press the sync button. That sync button will then cause the mount to be exactly correct in terms of its coordinate system, at a minimum right there at that object. And now if you move around the sky in local areas around that object that you synced on, you get very, very good go-tos. And this is true even if you have not that great a polar alignment. So when would you use this thing? Well, it's especially useful. You must use it after a polar alignment, in fact, any polar alignment, physical or virtual. And the reason is because there still remains error. It's not been corrected by the polar alignment relative to the motor counts, and the main error is deck home. You probably will not have the deck in exactly the right position for the deck home position. And when you do a polar alignment, the RA home position is pretty much squared away. But in any event, when you first go to a star after a polar alignment, you probably will miss, and you center that thing up and press sync. In that particular error, the home errors will be removed, and now you'll be good to go on the next couple, assuming you have a great PA. If you have a bad PA and you do the sync on that object, you're good for that local region, especially in that local region. So, since most of us will have PAs that are not that great, particularly if we're using visual and we've done a 2-star, and you wish to go to a deep space object, this becomes a problem because you can't see the deep space object to center on it. So when you go to it and you miss it by a couple of eyepiece diameters or something, you don't know where to go to find it. So what you can do is you can instead go to a bright object near that DSO, and you would center on the bright object and sync. And now when you do a go to that DSO, which is dim, it'll be right on the money. And you don't have to be exactly right nearby, but you should be in the same local region of the sky. So you pick yourself out a bright star as you look around the sky that you can easily get centered on and find using your red dot finder and so forth, and get it centered up. Sync on that star and then go ahead to your DSO. So that's a very important function for sync. And it's a very common way. In fact, Meade implemented something they call high precision. And they do exactly that, only it has a little algorithm built in. When you tell it to do high precision location, Meade will go to a bright star nearby, tell you to center on it, and then push enter in their case, which performs a sync, and then it goes off to the DSO or the other object, and it's a 2-step process that's programmed. ExploreStars doesn't do that for you, so you have to just do that yourself. It's a very simple procedure. Believe me, you'll save yourself a lot of frustration if, when you want to go to a DSO and you're using a little telescope or a finder that you cannot see the DSO through, to go ahead and get centered on it so you can get it into your eyepiece. do this method instead. I think that's close to everything that you need to know to get ExploreStars going. So there you have it. That's the Explore Scientific ExploreStars in a nutshell for the iPad.